Hello everyone, welcome to my video tutorial for the Bubblelines Skin in Voyant. My name is Fabrizio Lacarra-Ramirez, and I'm a Digital Humanities Assistant for the DH Center here at San Diego State University. This guide is part of a series of mini-tutorials covering various tools available in Voyant for text analysis. If this is your first time hearing of or using Voyant, I invite you to explore our slideshow guides on Voyant Basics and Voyant Stop Words and Search Queries created by Kiona Kinshasa. Our DH workshop tutorial for Voyant for text analysis, created by Pam Lack, is a great supplementary resource to view afterwards. This mini tutorial will cover the Bubblelines Skin within Voyant, how to read a Bubblelines graph, how to edit displayed information, and how it can offer practical applications in analyzing a collection of texts. Alright, let's get started. For this demonstration, I'll be using a corpus featuring the works of Jane Austen. The Bubblelines Skin allows for the usage of many collections of text, and is most likely compatible with your own choice of corpus. Before we begin, let's discuss term frequency, as it is the basis for which the Bubblelines Skin is built upon. Term frequency refers to the number of times a word appears in a given text or corpus. In Voyant, each term is treated as a unique token, meaning that variations of words can yield different results. Let's visualize this by looking up two similar words in Voyant. The word female appears 33 times in the text, while the word females appears 13 times. We can use stemming to count term frequency of words and their variations. If we type female and put an asterisk at the end, we get a count of 46. This technique allows us to count term frequency for both female and females, resulting in a count of 46. All other configurations such as stop words, wildcards, stemming, and more are available in the Bubblelines Skin. If you'd like to learn more about configurations, please check out our other Voyant tutorials. The purpose of a Bubblelines graph is to help the user analyze term frequency within a selected corpus. On the graph, each unique text in the corpus is visualized as a line with bubbles on it. Each bubble represents an equally divided segment of text. If we have 10 bubbles per line, this means each text is divided into 10 equal parts. But what do bubbles have to do with all this? Well, these bubbles represent the frequency of selected terms within each segment of text. If we scroll over any bubble on the graph, we can see how often our selected terms appear in that particular segment of text. These numbers are the segment count. The larger the bubble, the more frequently the word occurs in the segment. Using a Bubblelines graph to analyze term frequency can show in which way the text is directed thematically. For example, a novel that has more occurrences of the title Mr. might feature a narrative which focuses on men, while novels with increased frequency of the title Mrs. or Miss are more likely to represent a story about women. When we examine a text, we go in with questions about the work and try to find an answer. Analyzing term frequency with Bubblelines helps us reach conclusions by presenting changes in data both numerically and visually. The color of each bubble relates to the color of individual terms we've selected. You can see the correlation on the top left of the graph. Note, you are not able to manually select the color of terms. Voyant will automatically assign a color to each new term you add. Terms can be hidden from the graph by hitting Hide Term. To have the term appear again, click Show Term. You can remove terms by hitting Remove Term. You can also add more terms by using the search bar at the bottom left. Hit Clear to remove all terms. If you're using a corpus with multiple documents, there's an option to remove or add individual documents from the Bubblelines graph. To remove documents from the graph, hit the Documents drop-down menu and uncheck the boxes of whatever documents you'd like to remove. Hit OK to confirm. To add documents to the graph, hit the Documents menu and check the boxes of any documents you'd like to add. Hit OK to confirm. While bubbles measure the frequency of terms within equal segments of text, the number value on the right end of each line measures the frequency of terms throughout the entire text. These numbers are the document count. If we add up the segment count for any document on our graph, the number we end up with will be our document count. Since this number measures all selected terms in a text, adding or removing terms from the Bubblelines graph will change this value. As you can see here, the graph including Mr., Mrs., and Miss has higher document counts than the graph only including Mr. and Mrs. Comparing segment counts with document counts is important in helping us analyze the text as a whole. If a term is very common in a segment, but not in the overall document, that segment might be significant. Alternatively, if a term is very common across a document, but not in a specific segment, that might be significant too. It all depends on the terms you choose and the questions you're looking to answer. If we want to view the graph without term bubbles overlapping each other, we can hit the Separate Lines for Terms button at the bottom right of the panel. This will create additional lines for each text depending on the amount of terms selected. Using this feature will also divide the document count of each text so that it reflects the term frequency of each individual term. Note that the order of separate lines is based on term frequency and may be inconsistent across the documents. The bubbles will always be displayed in descending order from highest term frequency to lowest term frequency. Miss is the term with the highest frequency in love and friendship, and therefore is displayed on the topmost line for the document. For Lady Susan, Mr. is the term with the highest frequency, and is displayed as such on the top line. The term with the highest frequency in Sense and Sensibility is Mrs., and it once again appears as the top line for this document. If we want to increase the amount of bubbles in our graph, we can do so using the granularity slider. This will increase the amount of segments in our graph, allowing for a more accurate representation of each term's frequency in a text. The granularity slider functions in increments of 10, with the lowest possible number being 10 and the highest being 300. Increasing the granularity means there are more bubbles, each covering a smaller segment of text. Doing this may reduce individual segment counts, but the document count will remain the same. Segment counts are lower when granularity is increased because term frequency is divided over more segments than before. We're using low granularity in this tutorial to facilitate learning the tool, but turning granularity up can have its values too. Finding the right amount of segments for your corpus is key to analyzing your data. Depending on the frequency of your selected terms, it's possible your visualization could have too many segments or not enough segments. A low granularity is great for high term frequency because it allows the term bubbles to show large amounts of data in a way that's easier to read. Using a high granularity with high term frequency will crowd your graph with bubbles, making the visualization tedious to analyze and hard to read accurately. You can sometimes use the Separate Lines for Terms option to separate the data, but when we get into the hundreds of granularity, areas of text with high term frequency produce data that is unreadable. Love and Friendship and Lady Susan are able to handle higher levels of granularity because their term frequency for selected terms is lower than the other texts. The terms are spread out more. A good point to remember is that unique words with less document frequency are able to better handle higher levels of granularity. Note: segments are always divided equally regardless of the level of granularity, and even when no bubbles appear for a given segment. Some bubbles are missing from our graph because the terms we've selected do not appear in certain segments of the text. When the term frequency for a segment of text is 0, no bubble appears in the graph for that segment. A limitation to be wary of is that the Bubblelines graph experiences problems while processing corpora that have many hundreds of documents in them. If any issues present themselves while trying to use Bubblelines, try removing some documents from the corpus as a potential solution. If you'd like to learn more about available skins, I invite you to explore our other mini tutorials in the series on Voyant for text analysis. Thank you for watching, and have a lovely day.